This video is sponsored by Brilliant.org. Alright, it's been a while, but I think it's time to make some progress on this home automation project. Today I want to look at Hue lights, but first a quick recap of where we got to so far because it's been about 6 months. We wrote a device registry service. This stores metadata about all of the devices. In the video about this, I said that each controller would push information to the registry, but I decided to swap this around. So devices are defined here in the registry and other services, the controllers, pull that information. Similarly, we made a config service and other services will pull configuration from there. Today we're going to build one of the controllers and you'll see how all of this fits together. It'll be a Hue controller. It needs to pull config from here and device details from here, devices in this case being the Hue lights. It then needs to expose an API to let us control the lights and it'll communicate with the Hue bridge to make that happen. I've already spent a while working on this service and I originally built it using a node library called Hue.j. Hue.j talks to the Hue bridge and you don't have to worry about how that happens. And it works quite well. I was going to make a video showing you how I built it and how to use Hue.j. But while I was planning the video, I decided to look at the Hue bridge docs on the Philips developer website. And it's actually got a pretty good and well documented API. And Hue.j then seemed like an unnecessary abstraction. So we're going to rebuild the service today without Hue.j. The rough plan is going to be firstly figure out how to use the API on the Hue bridge, understand how that works. Secondly, make like a proof of concept node service. And finally, build out that service so it integrates with the device registry and the config service, etc. Hue bridges have a helpful little tool built in that you can use to make requests to them. But first you need to find out the IP address of the Hue bridge, and you probably want to assign a static IP address to it as well so it doesn't change. You can usually do that by logging into the settings page of your router, then find the DHCP settings. You can usually map a MAC address to an IP address, so you need to find the MAC address of the Hue bridge. Once you've done that, you can go to the IP address of the router. So for me, it's 1.110/debug/clip.html. And I don't know what clip stands for, but it gives you this little website that you can use to make requests to the bridge itself. Before you can do anything useful here, you need to create a user and authenticate. To do that, you want to hit the /API endpoint. And in the body, you want to set device type. And I think this just needs to be the name you give to your user. You want to send that as a post request and it'll tell you that the link button is not pressed, so you need to go and press the button on the front of the Hue bridge and then do it again. You get 30 seconds to press it again and it'll give you a username back when you do it. So we want to make a note of that username. You should now be able to use the other endpoints on the bridge by doing /API, the username that we just got given, /lights, we can do a get and that'll tell us all of the lights that this Hue bridge knows about. You get an object back. The keys are the Hue IDs. So then on the end of this, if you add / an ID, so one I know is the lamp on my desk here, /state, you can then set, I think it's called on to true, and send that as a put request, and it works. That's really cool. That's really easy. That's how the API works on the Hue bridge. Now let's think about the API that we want our service to have. So first we want an endpoint that can get device state. There should be a get endpoint. You do /device/device identifier, which would give us a 200 back in the normal case, along with some JSON that first has some metadata about the device, and then it's going to have a state. So this is going to be something like brightness, and instead of it just being a value, it can be an object. So this can let us define extra metadata about it. So we could have the type might be int with a min and a max, and then finally the actual value. And this means the front end in the future when we build it can know how to render this in the UI. We'd also want one for updating. This can be a patch endpoint, and that means we can just send a partial entity. So if you only wanted to update the brightness but not the color, you could just send the brightness and not the color. That's how patch is supposed to work. The arguments would just be the properties to change. That would give us a 200 back as well. And the response that you get, the JSON, would just be the same as from the get endpoint. Alright, let's create a node project. I don't actually have Node installed locally. And I don't need to because everything in this home automation project is going to run in Docker when I'm running it locally. So from Node, I know that I want to install NodeMon, which lets you do live reloading. Every time you change some code, it'll restart the web server. Then the command for running can just be npm start. We can create docker compose.yaml. Volumes, we want to mount service.controller.hue. We also want to add a volume that's user source app node modules, but it doesn't mount anything there. That's because we already have stuff in that directory in the image that's from the npm install, and we don't want to overwrite it. So naming it as a volume just kind of protects it, and it doesn't get overwritten by this volume mount above. To create a node project, you want to do npm init, which is really easy if you've got node installed locally. I don't. I think I can just do this inside of Docker. There we go, package.json. Do docker compose up again, and it just fails because the start script doesn't exist. I want to create start, does nodemon index.js. Hello, Hue. Okay, so it prints it out and then nodemon just waits for changes. We need some dependencies. We need Express, which is a web framework, and we need Axios, which is an HTTP client. Alright, let's put something more interesting in index.json. I want to require Axios and Express. You should always use const where you can. Const just means you're not going to change the value of the variable. So we create an instance of Express, and then do app.use express.json. That adds some middleware, which will pass the bodies of incoming requests as JSON. The idea with Express is that incoming requests are handled by functions, but not just one. You can have a stack of functions, and they're all called middleware. So app.use adds the first function, the first item of middleware that handles all incoming requests. We can then add a second one by doing app.use, and instead of express.json, which just returns a function, we can create our own function. So this one's just going to log all incoming requests so we can see what's going on. And then we call next, so that passes the request onto the next item in the middleware stack. We can add the next item, app.get instead of app.use would add a function that is only called for get requests. So here we want to make a request to the bridge, and we can use Axios. So /lights on the end of the normal URL should give us all of the information about the lights that we saw earlier that the Hue bridge controls. This returns a promise, so we have to do .then on it. I'd really recommend reading about promises and practicing how they work a lot in JavaScript. They're super useful, super important, but it took me a while to get what's going on and really understand it. I just had to try it loads of times. It exited immediately because we forgot to do app.listen on the end. Down here I should be able to make an HTTP request to this. There we go. So you can see we've handled the request, we logged the response we got from the Hue bridge, we also returned it on the bottom here in the API response. Next thing I want to add is an array of the devices that this service knows about. So this service is going to keep track of the devices and the device's state in memory, but let's add some convenience functions around this so we can access it easier. Let's find by Hue ID, find by identifier. So like our internal ID that we use, and so desklamp. Desklamp is the identifier, and then 1 is the Hue ID. Let's then add a function called fetch all state. Set device.state.power.value to be response.data. Hue ID, we need to use the square bracket syntax there because Hue ID is a variable. .state.on. We're going to call it power, Hue calls it on. So when the app starts, we want to just call this function. And now our get endpoint, the get device/device ID, this doesn't have to make any requests anymore. This just has to do find by identifier. Something like this should work. There we go. So the response that we just got at the bottom here is essentially this JSON object here, but with the actual values. So it's brightness 254, but the power is off, it's false. Let's add our patch endpoint so we can update this. So after get, we can also do app.patch. The state that we want to apply to the light is just going to be the body of the request. Now instead of applying this straight to the device object, we want to send the state to the Hue bridge, get the new state back from the Hue bridge, because the Hue bridge is going to potentially do some validation. It might reject the state that we send to it. So we want to see if that works and get the new state back, then apply it to our in-memory view of the device. Let's write a new helper function alongside fetch all state. Let's also do apply state. Then we want to do axios.put. It should probably be a patch endpoint, I think, that the Hue bridge has, but like, who cares? Nobody actually sticks to these conventions very well. Let's just assume it works and not do any error handling here. We then want to get the new state. Unfortunately, the bridge doesn't return the new state in the response, so we need to make another get request to get that. So now, in our patch endpoint, we can just call apply state with the device and with the state. Okay, amazing. Now it returns the JSON that we expected with a value to true for power. And I bet if we set power to false, it goes off again. Yeah, amazing. It works. So this is kind of it. This works. Let's refactor it a little bit so it's not all in one file. We're going to refactor it into like 3 sections. We're first going to have a module called API. That's where interactions with the Hue bridge will live. So that's where we'll make the requests to the Hue bridge. We then want to have one called DAO, Data Access Object. This is typically where you put your code that interacts with the database, so it's where you write your SQL queries. We don't have a database, we just have this array that's held in memory, but we can still abstract away the access to that through the Dao package, I think. And finally we're going to have roots, which is where all the functions that handle the endpoints will live. Let's start with the API. And let's create a file called Hue client. We can make a class here. JavaScript has classes now. So here we can create a fetch all state function. Also fetch state to get one device and also apply state. This class is only going to care about Hue interactions. It's not going to care about our representation of devices. So this just needs to take a Hue ID and the state rather than the device and the state. It's like one level lower than that. Fetch all state is going to be somewhat similar to this. Let's just copy it. If we make this an async function, we can then use the await syntax. So this lets you write it as though it's synchronous code. It's really important to understand that it's not though. This is still a promise and this works in exactly the same way. This is just different syntax so instead of doing .then, you do await. Fetch state is like really similar but just for one light. And apply state, let's just steal some of the logic here. Alright, perfect. Then at the bottom, we want to export something. We only ever want one instance of this Hue client, so we can just instantiate it here, and then export it. And when you do require in Node, it caches the result, so it only ever will call this once. And anytime we require the Hue client after that, you just get this cached copy of the Hue client, the cached instance. Let's move on to the Dao package. So this is going to use the Hue client. Let's just take our devices array and the find bys and the fetch all state and the apply state. Basically everything, except now fetch all state and apply state can just make function calls to the Hue client instead. Alright, finally let's do our roots. Fix my various typos. Where's that? Dao index line 39. Ah yes, Hue ID to state. There we go, it works now. So now we've got a nice refactored version of this. The only thing left to do is to read from the other services, the device registry service and the config service. I'm just going to copy those other services in here. Alright, I think they're all running there. I'm just going to register the device. So now in the DAO file, instead of specifying this thing manually, we want to just fetch that. Alright, for the config service, let's just do this in the main index file. So before we fetch any state, we can just do axios.get. And the config service has the Hue, the host and the username. Then we can do DAO.fetchState. Alright, it works. I think we're done. This has been a deeper dive than normal into writing a service. We've covered using the Hue Bridge API, creating a Node application, using Express as a web framework, using Axios to make HTTP requests. We defined an API and talked a bit about why we'd use the patch method. We created the handlers and we got everything working. We refactored it into something a bit nicer and more scalable using different modules. And finally, we hooked it up with the config service and the device registry service. I hope this was useful either to learn about communicating with the Hue Bridge or from just a general software development point of view. Please give me feedback, leave a comment, tell me if this video format works for you, what was interesting, what I should keep doing and what I should stop doing. If you have learned anything today and you want to get better at this stuff, then you should definitely practice, you should write code. Like I said with JavaScript promises, it took me a while for that to click in my head, and the only way I got there was from trying it out and applying it to real problems. It's definitely the best way to learn, and that's exactly what you can do at brilliant.org. Brilliant are kindly sponsoring this series of videos, and they've got loads of really interesting courses, and the method of learning is all based around solving problems. So the courses cover maths, science, computer science. Since I made the last video, they've added some new courses, including programming with Python. So the device registry service that we built in a previous video was written in Python. And if that was new to you and you want to learn the language properly, then this course is ideal. It'll guide you through the fundamentals. And instead of just watching a YouTube video where you get to interact with the lesson and write code and check on your progress as you go, everything comes with explanations, so you understand what's going on. And there's a community of people there also learning and helping each other. It's really cool. They've got daily challenges in math, science, engineering, so you can learn something each day. You can sign up for free at brilliant.org/JakeWright, and if you use that link, you can get 20% off the premium subscription, which gives you access to the interactive courses and the daily challenges in the archives. Let me know what you think. Again, also give me feedback and thoughts on this video. Thanks for watching.